Good evening, my YouTube viewers. In this video, what we're going to do is we're going to talk about a sample distribution of sample proportions. And so this is to do with the proportion of successes in a series of trials. So when you have a trial, you're going to have a 0 or a 1. So a 0 is going to be a non-success and 1 is going to be a success. And so basically this is a little bit different type of distribution. So we're going to work on this problem in Python, and so in order to execute the program, what we need to do is we need to import the libraries that we're going to need to execute the program. So we're going to import NumPy as NP, which is the numeric library, and we're going to import matplotlib.pyplot as PLT, which is the visualization library. So we're going to simulate a population with a binary outcome of 1 for success and 0 for failure. So the first thing we want to do is we want to set our seed. So when you set your seed, that means every time you run the program, it initializes with the same data. So np.random.seed, and then you can put any number you want inside the brackets. The population size is going to be 10,000. The population proportion is 60%. So it's 0.6. And then you're going to define your population as np.random.choice. And it's going to be 0 or 1, comma. Size is population size, that's 10,000. And P equals 1 minus population proportion, and that's going to be 0.4, and then population proportion, which is going to be 0.6. Now we're going to set our parameters for sampling. So sample size is going to be 100, and number of samples is going to be 1,000. So we're going to collect the sample proportions. We're going to do that by defining the sample proportions, which is an empty list. So, and then we're going to have a for loop for underscore and range num samples, that's 1,000. Sample equals np.random.choice, brackets population, comma, sample size, comma, replace equals false. Sample proportion equals np mean sample. And then so what you're going to do is you're going to append the sample proportion to the sample proportions list. So that means you're going to get 1,000 sample proportions in the list. And then we're going to plot the sampling distribution of the sampling proportion, and we're going to do that by making a histogram. So plt.hist brackets sample proportion, comma, bins equals 30, comma, color equals sky blue, comma, edge color equals black, comma, alpha equals 0.7. And then plt.axp line brackets np.mean sample proportions, color equals red, line style equals dashed, line width equals 2, label equals mean. And then plt.axp line brackets np.median sample proportions, comma, color equals green, comma, line style equals dashed, comma, line width equals 2, comma, label equals median. Now we're going to add titles and labels to the histogram. So the title of the histogram is sampling distribution of the same proportion of sample proportion. X label is sample proportion. Y label is frequency, and you get a legend, and then now we're going to show it. So you can see that the sample proportions have made a normal distribution as well. And so the red dashed line is your mean of 60, and the green dashed line is a median of 59. And basically, so the sample of the sample proportions gives you a normal distribution as well, even though uh, the numbers that we gave you on the population proportion was either 0 or 1. And then you had a percentage of it was 40% if it was 0, and it was 60% if it was 1. So there's your sampling distribution of the sample proportion. And in the next video, we will be talking about some more distributions. So look forward to communicating with you then.